Hey everyone, it's Mike. We've got quite the task ahead of us. We're going to find all the zeros of this polynomial, and I'm going to start off with Descartes' rule of signs. So let's see here, no, and then yes, plus to minus, so that's one switch, and two switches. So we have 2 or 0 positive roots. And now let's go ahead and let's find h negative x. So that's going to be minus 2x to the fifth plus 7x to the fourth minus 18x squared plus 8x plus 8. So let's count. That's 1, 2, 3 switches there. So that's 3 or 1 negative roots. Okay, 3 or 1 negative, 2 or 0 positive, and next I think we're going to look for rational zeros. So that's 2 has as factors 1 and 2, 8 has as factors 1, 2, 4, and 8. So we'll do 8 divided by 1 is 8. I'm going to write down possible. We've got plus 8 minus 8 plus 4 minus 4. Let's see here, plus 2 minus 2. Then dividing everything by 2 gives us 4, 2, 1. Oh, and 1/2. Oops. Didn't write that down. So minus 2 plus 1 minus 1 plus 1/2 minus 1/2. That is all of our possible roots. Okay. I'm going to start over here with negative 1/2. I think I want to start with negative 1/2. I'm going to work my way through doing synthetic division. So negative 1/2, and my coefficients are 2, 7, 0, right? Because there's, call it plus 0x cubed. There's no x cubed term there. So 0 minus 18 minus 8 plus 8. Okay. So we bring down the 2. We get negative 1, 6, negative 3. 3/2. So that's negative 3 over 4. 18 minus negative 3 over 4. God. 18 times 4 is going to be 72 plus 3 over 4. So that's 75 over 4. So this is negative 75 over 4, which is going to become a positive 75 over 8. I don't think this is going to work out. So negative 64 over 8 plus 75 over 8 gives us 11 over 8. So we've got 11 over 8, which will become a negative 11 over 16, which is not 0. Shoot. So it's not minus 1/2. What about plain 1/2? I don't think these fractions got too bad, did they? 2, 7, 0, negative 18, negative 8. Let's get rid of this scratch work here. Probably going to need more space for scratch work anyways. Positive 8. Alright, so bring down the 2. This becomes a 1. This is 8. So, oops, not 8, but 4. Bring down the 4. This is now 2. So then this becomes negative 16, right? So And this becomes negative 8. This becomes negative 16. This becomes negative 8. This is 0. Whoa! We just found our first root. 1/2. That is a root. So, okay, so let's go ahead and let's rewrite it. Now that we've done some division, h of x is going to be equal to x minus 1/2, I guess, times 2x to the 4th plus 8x cubed plus 4x squared minus 16x minus 16. And if you'll notice, we could pull out a 2 out of all of this, so it's 2 times x minus 1/2 x to the 4th plus 4x cubed plus 2x squared minus 8x minus 8. Cool. So now we have this to work with. And I think we're going to go all over again with this little part of our expression and start pulling it apart and looking for its roots. So let's go ahead and let's copy it. And let's jump to our next layer here. And we'll work with this now. Okay. So I'm thinking the same thing. We still know our roots of this are going to be negative 8 divided by 1. So our roots could be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So let's do some more synthetic division. And let's try to do 1 into 1, 4, 2, negative 8, negative 8. And again, we're doing just this 4th degree polynomial. 5, 7, 7, negative 1, negative 1, negative 9. Shoot. What about negative 1? 1, 4, 2, negative 8, negative 8. So 1, that makes that negative 1. 3 makes that negative 3, so negative 1 makes that positive 1. Negative 7 makes that positive 7, negative 1. Shoot. Another one of those. Okay. Let's take a look at a positive 2. Oops. 2 dividing into 1, 4, 2, negative 8, negative 8. So bring down the 2. 2, that makes 6, 12, 14, oh my goodness, 28, 20, 40, 32. Nope. Negative 2. 1, 4, 2, negative 8, negative 8. 1, negative 2, 2, negative 4. That makes negative 2, makes this a positive 4. Negative 4 makes that a positive 8. Boom, 0. So negative 2 is our another root. And we can rewrite this all again. So we've got our polynomial broken down this far, and we're looking at x cubed plus 2x squared minus 2x minus 4. Our possibilities are plus or minus 1, plus or minus 2, plus or minus 4. All right. Except, oh gosh, you know, I think I see something here. I really do. I don't think any of these are going to work because I'm suspecting the book to be a little bit tricky. And 2, 4, 1, 2, 2, 4, twice as much. Same sign, same sign. X cubed plus 2x squared. I can factor an x squared out of this, and I get x plus 2, right? Minus 2x minus 4. I can factor 2 out of this, and I get x plus 2. All right. So I think this means that then x squared minus 2 times x plus 2, h of x is equal to 2, x minus 1/2, x plus 2, x plus 2, x squared minus 2. All right. Would we have found that if we'd have used synthetic division? I think so. I think if we'd have done minus 2 times 1, 2, minus 2, minus 4, we should have been able to find it, and we would have gotten there eventually. It just would have been a matter of actually getting there and working our way through all of these. And then lastly, it looks like we just need to worry about this right here. X squared minus 2 gives us x squared equals 2, gives us x is equal to plus or minus the square root of 2. So I think with that done, we can write all of our zeros out. X is equal to the set 1/2 minus 2 plus the square root of 2 minus the square root of 2. We found all of them, and what's even more is we had this repeated root. So we did account for all 5 degrees of x because of that repeated root. And we could also rewrite h of x, I'd say in one of two ways. 2x minus 1/2 x plus 2 quantity squared, x squared minus 2. Or we could write it as 2x minus 1/2 x plus 2, x plus 2, x plus the square root of 2, x minus the square root of 2. That works. We don't normally factor something out with irrational values like that, but it still works. It would still be true. And we found all of the roots, more importantly. We did what we set out to do. Excellent. Great job. I'll see you next time.